Welcome back to another AP Pre-Calc video. Today we're just going over a little bit of a review. We've talked about a lot of information. We've talked about mainly definitions up until this point. So we need to make sure that we understand those different definitions. Wow. Okay, we need to understand those definitions. So we're just going to go through this review that we looked at in class, just making sure that we understand what everything is asking. Okay, if you hear decreasing, okay, notice what they're saying is where the function is decreasing. Okay, so I'm looking at the graph. I need to know decreasing. I know decreasing is when the graph goes down. Okay, so now I can look at my graph, see what intervals that might happen on. And I think these are the two sections the graph goes down for. So, okay, just label those two sections then. So that would be, we can use parentheses for this. That's fine for right now. Well, that started at the x value, -3, and that went all the way down to the bottom of this, which is, get that out of the way so we can see it, which is -1. Okay, so it looks like one of our intervals is -3, -1. And then the other interval started at the top of here, and it went down over to here. So it looks like that interval would be from 1 to 3. That is our decreasing section. Increasing, very similar, right? So function increasing, that's the function going up. So, okay, just find the two sections where it goes up. I guess this is one that does have two sections. And then state the intervals. So -1 to 1, as well as 3 to 4. Okay, there is A and B. Well, this next one is where people, I feel like, start to get thrown off. It says rate of change increasing. Well, that is a definition that we've heard. Rate of change increasing. You have to think back, try and remember, what does that actually mean? Well, if your function has a rate of change that increases, that means that your graph is concave up. The next one will say rate of change decreasing. That would be concave down. So all they're looking for C and D is the exact same thing they're looking for below that for E and F. So, okay, let's look at our graph and see where it is concave up. I believe my graph is concave up till right there, where it flips and is now concave down. But again, it flips one more time and it goes concave up again. So create your different intervals. The rate of change is increasing, concave up. That started at the left of my graph, which was -3, and stopped on the y-axis of 0. It began increasing again from 2 to 4. Again, that's the rate of change increasing. Rate of change decreasing, that's just the middle section, right? That was between 0 and 2 that it was concave down. E and F are just the same two answers, right? You take what you had for both of our answers, and that's what we get for these first few. There is the first part. Let's look at the other parts that they ask us. So now, get rid of that stuff on our drawing. Now they say determine if the average rate of change is positive, negative, or 0 on the given interval. Well, if we look at the rate of change between -2 and 3, right? They want the average rate of change during that time. Well, between -2 and +3, that'd be these two coordinates. So if I wanted to know the average rate of change, that would be connecting my two lines, which they just want to know whether it's positive, negative, or 0. It looks like that line is going down. I would put negative for that. Same idea for these other ones. Just take to C from -1 to +4. Is your line going up, down, or flat? In this case, it's going up, so I would say positive. Let me rewrite that so it's a little neater. 1 to 4, same idea. Just keep analyzing those from +1 to 4. Notice it looks like your two lines are just flat now. Because it's flat, that would be 0. And then the last one, -1 to 0, does look like it would go up during that time, so I'd put positive for that last one as well. Okay. Looking at this next side. Looking at the next problems, it says the number of local extrema. So they're asking for the number, so I just want to know how many there are, right? The number of, that's how many. Local extrema. Well, extrema were all of the relative or local maximums and minimums. Okay, so I know I have a minimum, a maximum, a minimum. But remember, when you look at relative or local max and mins, that does include endpoints. So if you look at both sides of our graph, there are no arrows, so it doesn't go forever. It does stop at those spots. Because it stops at those spots, those are included in the extrema. They are maximum, relative maximums or minimums. So in this case, I believe we just made 5 dots. How many of those are maximums? Well, how many of them are at the tops of whatever section you're looking at? That looks like 3. Minimums then would just be the other 2 of them. The number of changes in concavity. Well, if you go back to what we drew earlier, we knew that our graph was concave up to start. It changed to concave down, and then it was concave up again. So how many times does it change concavity? Well, it looks like it only flips 2 different times there. So the change in concavity is 2. Turning points is not one we've really talked about, but it is one that sounds exactly like you hear. It's where the graph turns. So if I'm looking at my graph, I want to know, where does it stop going down and it goes up instead? Or where does it stop going up and goes down instead? So if I look at my graph, I see there's a few spots that happens. Once right here at the bottom, at that minimum. It goes up, 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 and then it turns around there, and it will turn again at the bottom of this graph. I believe there's 3 turning points. Where does it change from going up and going down? The next thing we want to look at is, it's talking about multiplicity. Multiplicity at x equals 1. Well, that's right here. What I notice about that graph right there is our graph is hitting that spot and bouncing off of it. Well, remember, when things bounce off the x-intercept, that means that their multiplicity is even. We're just going to go with the lowest even multiplicity, which would be 2. Okay, well, at -2, what's happening to your graph? It looks like it's going through that point. Because it's going through, it would have an odd multiplicity. Let's just say maybe a value of 1. Looking at the next question R, it says the number of inflection points. Remember, an inflection point is where your graph changes concavity. It's where the rate of change changes from increasing to decreasing. Or it's where the rate of change changes from decreasing to increasing, right? It's where the rate of change changes. I believe our graph changed concavity 2 times, we said, so that would be the amount of inflection points as well. It changes from concave up and concave down at those blue dots. Distinct zeros, just how many x-intercepts do you have? Well, I see 1, 2, 3 x-intercepts. Continuing, the function's minimum degree if the graph is a polynomial. Well, we said that the multiplicity at these different spots was multiplicity 1, multiplicity 2. And this one looks like if you were to draw that line, it'd keep going through, right? It's just an x-intercept. I believe that one would be multiplicity 1 as well. So what is the minimum degree that we could have? Well, if we added all of those together, the degree would be 4. Notice that makes sense if you were to draw the lines going up. It does look like both sides go the same way, so it does make sense that the degree is even. Okay, that does make sense for our logic as well. Open intervals where the function is negative. All right, function negative, that's where the graph is negative. It's negative if it's below the x-axis. That would be this entire section. But realize in that section there, it touches the x-axis at one spot. Right here at 1, when it touches, it's not negative, it's equal to 0. So really we have two sections where our graph is negative. It's negative from -2 to 1, and then it briefly touches a value of 0, so it's not negative. But then again, it goes back and it's under 0 between 1 and 4. So it's not negative at 1. That's why we use the parentheses there to show that 1 does not actually work. If it did work, you would use a bracket. Brackets show that it can be equal to something. In this case, though, it is not. Open intervals where it's positive. I believe that's just the left side of our graph from -3 to -2. Domain is the x values of your function. So what are we restricted in between? We're restricted between -3 and 4. Is the function even, odd, or neither? So look at the graph. Can you cut it over the y-axis and it's symmetrical? No. Can you spin it around the origin and it's the same? No. So I would put neither for that. What interval is the rate of change the greatest? So again, just start drawing your different lines and seeing which one might be going up faster. So -1 to 1, that looks like it's going up there. And then from 1 to 3, it looks like it's going down. So I'd probably say the positive one is greater. Which one is the least? Which one is the most negative? -3 to +1, or 1 to 3. If you were to actually look at those, let's draw those a little bit better. So -3 to 1 or 1 to 3. That's going here, and then this one's going down there. They look pretty even, but see which one goes down further, which one's going down faster. I don't remember exactly which one I put. I believe I put the first one was going down faster. But that looks like it could be pretty open to interpretation because it looks like they're going down very similar. Okay. I don't remember which one I put, but both of them look similar. They're both decreasing very similarly. Last two answers then, last two questions, more of some open-ended questions instead of just that graph. This next one is a really good question that I like. They give us this function where they've shown 2 zeros. They've shown part of the graph. We don't know what the rest of the graph looks like. We need to talk about the zeros. Is there another 0 or not? Well, I know that this function is negative and it's x cubed. Well, a negative and an odd degree would have ends that look like this. Well, notice both ends right now. The left end is going up like it's supposed to, but the right end is also going up right now. And that doesn't make much sense for this odd degree. So we know that this side will have to turn eventually and come back down. It would go down forever as its end behavior. So there will be another 0. There's not going to be 2 zeros. There's only going to be one of them. And again, it's not a double 0. It's just one. There's going to be another 0 that exists. We know it's positive because it's on the right side where the positive values are. Last one, which of the following represents this graph? Notice your degree. In this case, if you add them all up, 2, 1, 1, our degree would be 4. And in this case, we have a negative coefficient. So it's negative and even. Both ends would go down. Find the graphs that have that, so B or D. And then you can check the x-intercepts as well. Which one has the correct x-intercepts? Well, if you solved x plus 1 equal to 0, you'd get x equals -1. If you solved the next one, you'd get -4 and +3. So double check, see which one has each of those. I believe that is answer B. That's our review. That's what we need to know for our quiz tomorrow. A lot of definitions and applying that stuff. What does it actually mean?